Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. This episode is brought to you by L1 Automotive Training and Keith Perkins. If you're looking for education on module programming, J2534, EEPROM work, key and immobilizer, electrical diagnostics, or drivability diagnostics, Keith has a website, l1training.com, that's got over 60 hours of training videos on all those subjects and more. When I first started out doing mobile, I utilized Keith's videos on module programming in J2534 in order to get my head wrapped around what I would need for the tooling, the computers, the software setups, what kind of obstacles I would be up against when I'm out there programming modules on cars. And it was a huge benefit to me. And I continue to use the training videos that he has on his website. So I strongly recommend checking out l1training.com. We have got Auto Rescue Tools and Isaac Rodell as a sponsor for this podcast. Hey guys, if you're looking for programming laptops, you want the laptop set up ready to go for programming control modules on vehicles, you need key cutting equipment, you need diagnostic tools, Isaac is your guy. Has all that stuff available for purchase, and the support that he offers along with the purchase has been outstanding. I bought some stuff from him in the past. I got my Dolphin key cutting tool from him several years back. And again, the support has been phenomenal. Helped me out along the way with anything additional I needed to make it work for me. Also, for the month of June 2023, they've got Autel updates for sale. So make sure to check that out as well. Again, that's autorescuetools.com. The link will be in the show notes. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and I'll be your host once again for this week's episode. Thank you so much for joining me. This week on the show, I'm going to go back over a topic that I covered briefly in a previous episode. The episode was 190, replaced with known good part. I talked about a camera tester, a CC or closed circuit TV tester that I've been using to help me diagnose camera problems on vehicles. And I had a lot of questions about this through various methods, email and Facebook Messenger, and tried to supply everybody with the information that I had about utilizing this tool and how it's been helpful to me. But I figured since I had so many questions about it, there's probably other people out there wondering details on this thing. So I'm going to go over that in this episode, talk about the tool, how I utilize it, but then also just go over a couple vehicles where I used it and even some other methods that we can utilize to help us diagnose camera problems. Right now, more than ever, we're seeing cameras on just about every vehicle. Backup cameras been popular for a long time, and that was the number one thing that we did with vehicle cameras is if there was an issue, it was the backup camera. So you had one camera on the vehicle. Well, now we have multiple cameras, and there's a round view in a lot of different applications that we see on vehicles now. And so now we're going to have at least 4 cameras. There's going to be the one in the back. It's still used as a backup camera, but there's also cameras on the side view mirrors and somewhere up on the front of the vehicle in the grille. It produced the around view picture for the vehicle. So we're now going to have 4 more that we're going to be testing or looking at diagnosing. And so the odds of us running into trouble with these components are going to be that much more. So you're going to be able to utilize this knowledge, these skills, these tools, even more so. Now, the one application where this probably doesn't apply is going to be the camera that's used in the actual ADAS functions of the car, meaning the one that's mounted up on the windshield in front of or behind, however you look at it, the rear view mirror for identifying objects on the road or the lines on the road, right? That's actually used in vehicle control. This tester, as far as I'm aware, correct me if I'm wrong, is not going to be utilized for something like that. Those systems, from my experience, that camera that's mounted up on the windshield for the ADAS systems, that's a lot of the time going to be its own control module with its own self-diagnostic capabilities. And so there's a calibration that's done with ADAS equipment for these if a windshield's replaced or a component's replaced. But the diagnostics on these up in the windshield is generally going to be done solely with the scan tool and maybe some power and ground checks, and that might be it. Of course, there's always exceptions to the rule, and again, someone can correct me if I'm wrong, but I just wanted to be clear. My focus today is on the smaller, you could say less important cameras on the vehicles that are just used for parking lot functions, right? The around view that shows you the above view of the vehicle as you're navigating through a parking lot, or just the backup camera that comes up on the infotainment screen or wherever the screen is to show you the view behind your vehicle. So that's what I'm referencing here, and that's where I've utilized this tool. So again, I'll put a link to this tool in the show notes. First thing is, I'm sure it's not the only one of its kind. It's just the one that I found a few years back when I was doing some searching, because I didn't have much for diagnostic capabilities of cameras other than power, ground check, and replace if everything's good. But this is a closed circuit TV tester, and it's not even built specifically for automotive applications. Its purpose is for closed circuit TV cameras, which is like the little security cameras that you might see hanging on the wall at a business or something like that. You could use it for something like that. But the technology in these automotive cameras are going to be very similar. The protocols, the communication protocol that's used to transfer data that's transferred into an image is going to be similar or the same as these other cameras. And so we can use this tester in the same way, and it's going to show us what we want to see. Now, this is a battery powered unit. It fits in the palm of your hands, has a screen on it, and it's got basically an input and an output. And it actually has some other connections. There's a USB connector. There's an HDMI connector. I think you can hook it up to a bigger screen if you want to. But the handheld version is very nice, because when I'm doing this testing, I'm generally under a car, or, I'm in the back hatch of the vehicle, or, under the hood, or wherever the camera is that I'm testing, and having a little handheld is very nice. But it's got an input and an output. And that's where I found this thing to be really useful. And they're both BNC leads, right? So if you have a scope lead that has a BNC connection, you already have the lead that you're going to use to connect to this tool. Now, it does come with an attachment for one of those BNC leads, but I like using my scope leads because they're already set up with the banana jacks, and I already have all the adapters I need for the banana jacks, right? Am I using a back probe or one of the leads from my ASE Wave U-test terminal kit, right? I can connect all that stuff to there and get into the circuit however I need to. So anyways, I'm just going to connect my scope lead to either the input or the output. Now, the input should be easy enough. We're going to connect that up to the signal wire of whatever camera is in question. And the output of that camera is going to be fed into my tester. This thing seems to, from my experience, automatically detect the protocol if it matches one of the protocols that it has programmed into it. And it's going to buffer a little bit, and then it'll pop up with a picture that's coming out of the camera, again, the camera in question, if it's there. Now, this is when we would connect up to the signal wire and everything's turned on, right? And that is something to note, is you need to be aware of the vehicle that you're working on. When does that camera actually output a signal? There are some cameras that will output a signal as long as the key's on and it has power and ground. And let's say this is a backup camera, and there's a screen, your infotainment screen. The camera's always outputting a signal, but it's not shown on the screen unless you're in reverse, right? There's applications like that, but there's also applications where the camera doesn't output a signal until it's requested maybe via a LIN bus or a separate circuit, that, hey, the vehicle is in reverse. And now the camera is going to output a signal. So just be clear on when that camera should be outputting a signal. The easiest way to do it for me is to put that vehicle in that state. Now, the exception might be is if it has to be in reverse and running, I'm going to need a second person for that. But I do want to be sure that, okay, when is the camera supposed to output a signal? Now, you can do this scope wise too, and I use my U-scope a lot for this. You can connect your scope to the signal wire. And I had done that prior to buying this CCV TV tester, is just connect my scope up and there is a signal. There's voltage there, and you can actually watch that voltage. If you hold your hand over the camera, you'll see it change, and as you move your hand away, you'll see it change again. And it's a waveform. I don't understand it. There's obviously a protocol to it that certain voltages are going to correlate to an image, and pretty crazy that somebody figured all that out. But you can move your hand across the camera and verify that, oh yeah, that camera is doing something. Now, you don't know, is it actually producing an image? You don't know how clear that image is, but you could say that yes, something is happening there. And if you weren't sure, is this camera outputting anything or not, you could use your scope just for that function. But I do like to see a picture, right? Because if I can see a picture when I'm tied into that signal line, that means the camera's doing something. And the whatever screen or module that is supposed to take that camera signal and convert it to an image should be doing it as well, right? So that's why I really like this thing. It's proving out that the camera can produce an image. So it's really as simple as that. Tying a BNC lead into the signal wire. And I do have a caveat there of why that might not be so simple. But then you connect the other end to the CCV tester, you turn it on, and it will automatically recognize the protocol and pop up with a picture on your screen. Sweet. So we can see if the camera is outputting a signal. Now, the more difficult connection would be, and I'm seeing this more and more in vehicles, so this will be something where I've got to figure out how I'm going to get around this. But a lot of these cameras seem to be using like a coax style connection. A lot of the newer ones are like this. So I can't exactly back probe one of those wires. You would almost need some type of an adapter or find a place within the circuit that you would be able to tie in, maybe at the module, maybe not, depending on, does that have a coax style connection as well? And when I mean coax, I mean there's, if you disconnect it from the camera or wherever it's connected, there's a wire, a very small wire in the middle of this cable, I would call it, and that's your signal wire. And then around it is going to be the ground for the signal. And every camera that I've worked on is going to have that. It's going to have the signal wire, and then it's going to have a ground for the signal. Now, the camera itself may have an additional ground going to it, and it will have a power as well. So you have power, ground, signal, and then you have a ground for the signal wire as well. But on those coax style, the signal's in the middle, the ground's on the outside. And so connecting to those can be a little bit more of a challenge. Again, that's a scenario where maybe building some adapters off of other vehicles or ordering some connectors might lead you to be able to connect to these things a little bit easier. But that's an obstacle that I'm going to be running up against with these newer vehicles. But a lot of the camera connections are just copper wires, and so we can tie into them like any other circuit. And those are the ones that I've dealt with mainly so far. Now, the other cool thing about this tester is it has a second BNC port to it, and it is an output, and they're just labeled input and output. The output, as long as the tester is on, is always going to be outputting the color bar test screen. And if you remember way back in the day, you'd see this on actual TVs when there was an issue with whatever channel, you'd see the color bar test. And it's just all the colors arranged in bars on the screen. Okay. And you can verify this. You can actually jump the output of the tool to the input of the tool, and on the tool itself, it will show the color bar test screen because you're just feeding the output into the input, right? But what this does, the input's really going to test the camera's ability to output a signal, where the output is now going to test the circuit's ability to actually transfer information and whatever receiving module or screen's ability to project said image. Because you know what's going out on there. You know it's a color bar test screen. And if you're injecting that into the signal wire, and again, you've placed the vehicle in the appropriate position for it to display, it should be displaying that. So you can test the circuit that way. And so we really gain a lot of ability here to assess the circuit and the camera being able to input and output. And that's why I bought the tool, because I thought it'd be really helpful, and it definitely has been for me. So a couple vehicles here that I dealt with that I utilized this tester. Neither of these are groundbreaking diagnostics or anything, but just kind of shows the ability of the tool and where it can be helpful. And I'll mention a couple other things that can be helpful in camera diagnostics as well. The first vehicle was a 2018 Nissan Murano. This had been in a wreck. It was at a used car lot / body shop. They'll buy wrecked vehicles from the auction. They'll get them back to working order. And this one had a wreck in the front, and the wiring for the front camera had been damaged. Shop said they bought a used camera for it. This is the front camera up in the front grill. They bought a used camera for it, and they got a connector. They wired it up, but the front camera does not work. And so if you do the around view, which this one had, you'd see an error message on the dash for the front camera. And I think on this one, it would show the other 3 camera views, but not the front one. And there'd be an error message on the infotainment screen. So obviously the front camera's not working. And I believe there was a code in the camera control unit that would indicate that there's a loss of communication to the front camera. Okay. So obviously front camera's not working. That's what we're after on this one. So the first thing I'm going to do is check my powers and grounds to the camera. This connector at the camera has 6 pins on it. There's only 4 wires going to it, but there's 6 pins on the camera. Now the shop wired this connector up to the car prior to me getting there. And if you imagine the pigtail and the small harness, or the connector and the pigtail that are on the camera, they replaced that portion. The wire colors on the connector and pigtail were different than on the vehicle harness side. So it was not as simple as just matching up the colors of the wires. They wired them up how they saw fit. And I'm not really sure how they determined, which wire went where. But the first thing on my mind is, okay, well, it's possible that they got the wires mixed up. They also have a used camera in there, and it plugs in, but it plugs into the connector that I have there. Again, I don't even know. Maybe that connector is not even right. The wire color is different, right? So it could have been from something completely different. These are all the variables that are going through my mind as I'm looking at this thing. But again, still just want to check for powers and grounds. In order to do that, I need to find a pinout of this connector. So when I was looking at this thing initially, I had some trouble finding a pinout for this camera. Now, I eventually did locate this. I was using Identifix, and again, had some trouble, but I eventually did find a pinout, not in the exact moment. And, sometimes when you're under the hood of stuff, I wasn't able to locate it. It wasn't easily accessible. Like Identifix has a tab for OEM connector pinouts, and that was grayed out on this 2018. So I wasn't able to go that way. It was in there. You kind of had to dig for it a little bit, but all I had in the moment was the diagram, which had the wire colors, which matched the vehicle harness side, but not this connector. And then it had the number of the pins, but I didn't see any numbers on the connector itself. Again, it's 1 through 6, and there's 4 wires going to this thing. There's a power, there's 2 grounds, and then there's the signal wire. And so I got to figure out which one's which. Of course, I can look at the wire color on the harness side. I can measure, and I did, and I had power to it, and I had my 2 grounds. We'll test the signal wire in a moment, but my question is are they going to the right place on this camera connector? And is the camera connector correct for the vehicle? Is the camera correct for the vehicle? Now, with a little bit of Googling, I was able to find that the camera was correct, at least the way it looked in the connector shape and size. So I said, okay, well, this camera does look like it's correct for this application. The connector also looks correct for the application. Wire colors are different, but it looks physically like the right shape for this thing. Okay, but again, are the wires going to the correct place on this camera? But before I did that, I wanted to check my signal wire and see if it was working correctly. And so what I did here was, with everything plugged in, I used the CCV TV tester to test the output of that camera when I had it placed. I think you had to have this one in reverse in order for the around view to initiate. And I did find, this is a little bit later after I got everything together, I did find that this camera doesn't output anything, or the signal wire doesn't have anything, unless the camera is going to be triggered to output. So you have to put it into that mode to get it to say, okay, I'm going to output a signal. Now, I didn't have anything on this wire here. I used the CCV tester, didn't show any image on the signal wire. So the next thing I did was I wanted to output a signal onto the signal wire right there. I was back probed into the camera, and I was back probed into the wire that was the correct color for my signal wire. And I'm going to now connect that to my CCV tester, the output function. I'm going to go in the vehicle and we'll look to see, okay, do I have that color bar test screen? And then I was able to get the color bars up on the screen at this point. So with the camera removed from the circuit and me going into the signal wire with the output from my tool, I was able to see it on the screen. So at this point, the screen, the module that receives it, and the circuit all appeared to be good. And again, I tested my powers and my grounds, and those were there as well. At this point, this is either a bad camera or it's pinned wrong. So I searched a little bit further into service information. I was able to find a pinout for this thing. And I went through and I matched it up to the connector I had, and it was in fact pinned incorrectly. I had to move around 2 or 3 of the pins to the correct place, just depinning them and putting them in the right spot. And then after that, the camera that they had actually worked, produced a signal. Everything was fine at that point, so it was pinned wrong. And so this little CCV TV tester was really helpful here. One of the other thoughts I had here, and I just wanted to mention this before I move on to the other vehicle, was on the cameras or on the vehicles with multiple cameras, with 4 cameras, the other option that you have if you don't have one of these testers, or maybe if you're just questioning, hey, is this tester correct for the application that I have, right? Maybe it doesn't work with the protocol that this vehicle is using. You do also have the option of jumping the signal from other cameras into the circuit in question, right? So you could take your rear view camera or your side view camera signal circuits, wherever you can tie into them, and that's going to base on the vehicle how easy or not easy that is. You could take those signal wires and you could jump them into the signal wire in question and see. You'd have 2 of the same image, essentially, or if you're disconnecting things, you're just moving it over to a different spot. But do keep that in mind, is if you're not using the tester, you still have 3 known goods in the vehicle. You could use that scope-wise, too. You could look at the pattern that's output from a working camera on that vehicle and match it up to what you have on the non-working camera and see what's going on there. That is an option as well, is to utilize your known goods on a vehicle if you have multiple cameras. So anyways, that connector was just pinned wrong. I don't know where the connector came from, different year or something, but once it was pinned correctly, the camera worked, everything was fine on that Nissan. That was an 18 Murano. All right, the next one that I used this for, this one actually took me a little while longer than I would have hoped to figure out or to really confidently say what the problem was. It was on some type of Chevy Silverado. The year doesn't matter because this was actually an aftermarket backup camera that had been installed with an aftermarket stereo system that had a video screen on it. So I think it was in the probably 2008 to 10-ish range truck, and it just didn't come with one. So they installed a camera on it. And this was on the vehicle for quite a period of time before I looked at it. So this wasn't a new installation. It had been on this vehicle, but they brought it to the shop for them to say, hey, my backup camera aftermarket is not working anymore. And generally, I don't really like getting into aftermarket component diagnosis because you don't have diagrams or anything like that. But I decided to take it on for the shop just because I was like, well, I could probably figure this out. This shouldn't be too complicated. So again, this setup is fairly straightforward on this camera as well. It's got power, it's got ground, and this one actually does have the, actually what it reminded me of was like the old AV connectors that you would see for like a old school video game, like a Nintendo or Nintendo 64, right? You had the red, the white, and the yellow. The yellow was for video, and the white and red were for the audio. The connectors kind of look like that. Again, this was aftermarket, but I wouldn't even call it a coax style, but it was similar to that. That was the signal wire for this thing, but it had the same idea as a coax style cable where you had the signal wire in the middle and then you had the ground for that signal wire on the outside. Now the camera itself had its own power and ground copper wires, and that's easy enough to check power and ground. Okay, it had power and ground to the backup camera, but the backup camera did not function on the screen of this aftermarket stereo system. You put it in reverse and it didn't work. Now, on this setup, this particular aftermarket setup, the camera would always output a signal when power and ground were sent to it, which was anytime the key was on. And then the radio had a signal wire separately to trigger it to say, hey, we're in reverse. And then it would change the screen. So they wired something else up into the range sensor of the car or whatever to switch it to the camera mode once you placed it in reverse. And the screen would actually switch when you did this, when you put it into reverse, but it would just be a black screen. And there was I think there was an error message that said no camera input or no camera signal detected, something like that on the screen. So the the screen was actually triggering. The radio was triggering when you put it into reverse. So again, going back to, we got to put the vehicle in the state where it's going to observe the signal. That seemed to be functioning correctly. Power and ground were present to the camera. So now it's just a matter of, okay, is the camera functioning? Is there a circuit problem? Or is it maybe still with the radio or the display itself? It's still possible. So again, I'm back at the camera itself, and I'm going to use my little CCV TV tester to see what's going on here. When I would disconnect the signal wire, because there was an actual connector back by the camera that you could unplug and access this circuit. When I would disconnect that, the power and ground were still going to the camera, and I would connect up my BNC lead that go into my CCV TV tester to the output of that camera. So I'm connecting up to my input to my tester to the output of the camera, the signal wire and the signal ground. And I actually saw a picture of the back of the truck, or wherever the back of the truck was looking. It was on my tester. Cool. Awesome. So the camera appears to be working. Okay. So let's go the other direction and see what happens. So I now switch over to my output, color bar test screen. I connected I'm at the same place. I'm way back at the tailgate of the truck here. And I connect that up to my signal wire going to the screen on the radio. And I actually had somebody up in the truck looking at it for me when I connected. And he said, yep, it shows the color bar on the screen. Okay, so my camera's working and I am able to put a signal onto the signal wire and it's working up on the screen. So everything's working here. And I first thought, I was like, well, maybe it's this connector that I disconnected. And so I, messed around with that. It looked clean. I reseated it. I looked at it for like, is there some sort of pin drag issue here? I couldn't find anything. It looked fine, but the same thing would happen. Camera showed a signal on my tester. The screen showed my output from my tester. Everything appeared to work, but when I would plug it in, it would still say no signal detected from the camera. I'm like, what the heck? So what I did here was, instead of actually connecting the connector together at the back of the truck here, I set up some jumper wires, and it was a little tricky to get them on the ground and the signal itself, but I was able to rig something up so I could set up some jumper wires on that signal wire and actually test it while it was all complete, right? So I want the camera of the vehicle connected up to the actual circuit and the screen of the vehicle to see what's going on when everything's plugged in. Why is the screen say no signal detected? So when I do that, everything's connected, vehicle's in reverse, shows no signal on the screen. Now I am connected to that circuit as well. I'm teed in, basically, if you want to think of it that way. And I no longer show a picture on my tester. And if I unplug it, if I take it away, now I have a picture on my tester. So it seems like when the circuit is connected, for whatever reason, the camera is not able to output a picture. But when we disconnect it, it can. So my first thought was like, well, maybe there's some sort of short or something with the circuit, but my tester is able to output a signal just fine, and you see it up at the screen. But for whatever reason, the camera seems to be unable to do this. But when connected to my tester, it's just fine. So my other thought was like, well, maybe there is some resistance in the circuit. This wiring was run underneath the truck, and it's aftermarket. It's not exactly, they did a fine enough job of routing it on the frame rail, but it's aftermarket. There could be some corrosion or resistance somewhere. Is the output voltage of my tester just a little bit more than the aftermarket camera? I don't know. I'm not really sure on that. I'd have to do the scope pattern to verify that's what's going on. So one of the things that I have found with a lot of these camera circuits, and I can't by any means say that this is across the board, but I've found it to be common, is that roughly 80 ohms of resistance measured. So let's say I'm back by the camera, I've disconnected it, and I'm looking at the signal line going towards my radio or whatever infotainment module takes the signal. And you measure resistance, and you want the key off for this. Measure resistance between the signal wire and the ground wire going to that camera. It should be roughly 80 ohms. Not perfectly, but roughly 80 ohms. And doing a little bit of reading on actual camera circuitry, there is a resistor in place with the receiving module that is roughly 70 to 80 ohms. And I found that to be true on multiple applications. Again, I'd be careful using this across the board. I'm going to keep trying it just to see. But I did get 80 ohms on this particular vehicle. Again, I'm not 100% sure if that's good or bad, but it matches things that I have seen before. So at this point, here's what I know. Power and ground is good to the camera. The screen seems to be able to take a signal through the entire circuit, all the way from the back of the vehicle to the front from my tester. The resistance matches what I've seen in the past for these circuits. And although the camera is able to produce a picture that I can see on my tester when measured at the back of the vehicle, when it's connected to this circuit, it's not able to do so. So it's like the camera is unable to output a signal when it's faced with the load of the entire circuit. And that's what I decided to go with on this one. I told him, I was like, get another camera. Now, are you going to be able to get the exact same one, the same connector? I don't know. That's on you guys. You'll have to do some searching to see what you can find. But I was like, get a camera for this thing, because everything on the truck side to me seems fine. The issue seems to be with this camera's ability to output. It can output, but it's not as strong of a signal as it should be. And it did confuse me for a little while, because again, I saw a picture out of the camera at first, but by testing everything else in the circuit, and everything else seems to be fine. That camera seems to be the issue only when it's connected to the full circuit. Let's replace this camera. So they did. They found a camera one way or another, and that ended up working, took care of the issue. So for whatever reason, that camera's output was weaker than it should have been. And that fixed it. So that's it for this episode. Thank you for listening. Hopefully you found that information interesting. There is a link in the show notes for all the sponsors, but then also for that CCV TV tester if you'd like to use that. With that all out of the way, let's get out there, start fixing the world one car at a time.